In this video, we emphasize merge sort. Merge sort is one of the algorithms solving sorting problem. It uses divide and conquer technique. Divide and conquer is a very important strategy in computer science. Given a problem, we would like to check if it could divide the problem into smaller parts, independently solve the parts, combine these solutions to get an overall solution. It also belongs to decrease and conquer technique. In the decrease and conquer technique, we talk about decrease by constant factor, and variation size decrease. Three types of decrease and conquer. Here we could know that it corresponding to the merge sort corresponding to decrease by constant factor, divided array into two halves, recursively sort left and right halves, then merge two sorts. This is related to recursive thinking. It is not easy, but once you're familiar with recursive thinking, it becomes very understandable. And then we have another algorithm, quick sort. It will be next video. And it's a partition array into items that are small and items that are large, then recursively sorted two sides. It corresponds to decrease to the different groups, decrease into the groups of different input instance size, right? Variation size decrease and conquer technique. In this video, let's take a look at examples and check for merge sort. And with the given example here, we have 8 long balls. And set up middle point and divide into two halves. In this case, they are not sorted, right? After you divide into two halves, you want to use the same procedure. You divide it and conquer it, and such that we expect to see, once you divide and conquer in these two halves, we expect to see the sorted results 2, 4, 8 line from the left part. We also want to see the sorted results from the right part. So you have a sorted list in the left part, sorted list in the right part. Then once we combine these two results or merge these two results, we got with what we want, right? You merge these two sorted lists. We talk about that one of the video. And in that case, we only need big O n runtime, and to get this merged results from two sorted lists. This is what we're supposed to say. Right? Okay. So take a look. Go to the details. Take a look at this recursion. We have two groups cut into two halves, and this is level 1. And from this level 1, we say this is the given original sequence. This is the follow merged results, right? And once you divide into two halves, it's two halves. Right? Based on this splitter. And follow the same procedure. So you have another group which hold for 2 elements and split it, and you have a smaller group which only hold for 1 item. And once you have this smaller group, you cannot divide it anymore because only have one element. And then you merge the results from this smaller group, adjacent group, and such that we see this is the merge results for this subproblem. This is the merge results for this subproblem. Same thing here, right? And once you have results from this subproblem, and we can merge this adjacent two group from the results from the previous level of the subproblem, and same thing here. And once you have sorted the two sorted results, we merge them, we follow the final results from the original problem. This is what we talk about divide and conquer. After conquer, we have to combine. Since this is recursion, once you finish the previous level, you will combine the results from the previous level, recursively work on that. Okay. And in this merge sort, we need extra array to save the merging results. And for the merge, give two sorted in this part. This is a sorted list for left. This is sorted list for left half. This is sorted list because we talk about the merging, right? And a sorted left. Let's write down here, right? This is the left. So this is the left. This is right. Both are sorted. And when you merge them, we use pointers from the left part and the right part, and compare the elements, pick up a smaller one, put in the new array from the beginning to the end, and then you move the pointers to next position and compare the elements in these two pointers, pick up a smaller one in this position. Continue this procedure until you meet the end of the left or you meet the end of right. Well, once you meet each one of the end, then in that case, you go to the special case and you pick up the remaining elements in the left or right. And here we show the cartoon picture of this three type of merging, right? Three type of cases, three type of situations. First one, you use pointers and we pick up elements in the left and right. And both these pointers is in the beginning or in the middle of elements, never go to the end of elements, right? Never finish that, never beyond the boundary of the left or right. And in that case, you pick up a smaller one in the point I or point J. So this is a normal case. If the left component, if the left half totally finished, if the left part of this one has been put in the new array, in that case, we have to copy the remaining elements in the right part. And the third case, it is if the right half has been finished, the right half or the right half has been filled in the new array, then in that case, we have to copy the remaining left and put in this one to the new array. This is the code for this merge procedure, and follow what we discussed. And first check if that is in the normal case, we merge from two sides. If one side is finished, the left side is finished, then we copy the right remaining elements, or the right side is finished, we copy the remaining in the left side. And this merge sort is based on what we give you the merge procedure and give the sequence, and we divide, find the middle point, and follow the same procedure and check the left part is the left part, and check the right part, and this is the combine the results from the two sides, right? And we can see this is the idea of merge sort, and the implementation could happen from the top to the bottom, right? From the top to the bottom. Give the whole array, and you set it to be 2 halves. You follow the same procedure, and you follow the smaller part, and you cut in the middle, put in a very, very small one, and then you combine the results, right? Then finally get the results. So this is from top to bottom. Once you go to the bottom, you can merge the results. And this is one of the implementation. While another type of implementation is based on iterative approach, and we set up the group, the size of group, from 1 through the n. In every iteration, we increase the group size, right? And also in every iteration, we merge adjacent two groups. In the beginning, the group size is 1. And we merge adjacent group and merge it by 1, right? We got group size 2. Then after that, in the second iteration, we merge adjacent groups, which each group has size 2 or less than 2, right? And then we form the group of 4. So in that case, we form group of 4, right? The size of group of 4. And then we merge in the third iteration. This is iteration 1. This is iteration 2. And this is iteration 3, right? In that case, it is in each iteration, we merge adjacent groups. We increase the group size we double increase the group size. Then we go to next iteration. So this is from bottom to top approach. And in this approach, we don't need to use recursion. We rather code the loop-based code. Okay, and then we have to check the runtime. Let's use Tn to represent the running time for array of n elements. Merge sort divides array in half and calls itself on the 2 halves. After retaining, it merges both halves using a temporal array. Each recursion call takes Tn divided by 2, and the merge procedure takes On. And such that we have Tn, you can directly write. Sometimes people like to use a smaller than or equal to. Sometimes we just write equal to because it will talk about asymptotic order. So it is fine. Plus n, right? Because we'll talk about the asymptotic order. And you can see based on what we discussed in the module 2, you can solve this one by substitution or master methods. And we see based on this one, we could have Tn equal to O n log n. This also give the proof. And here, we think since we talk about asymptotic order, and it's okay, you just use you can ignore the coefficients and the lower order term, right? Okay. And here, in this merge sort, we also consider the time, the space efficiency. We need to have On extra space. I think that it is for our merge sort for this video. Let me know if you have any question.